Hello friends, Standard 12 Chemistry, Unit 10, Haloalkanes and Haloarenes, Part 4. In third part, we learn about IUPAC nomenclature of haloalkanes and haloarenes. Today we are going to learn nature of C bond X bond. So first of all, here for X, chlorine, fluorine, bromine and iodine. For fluorine, atomic number is 9, for chlorine 17, for bromine 35, and for iodine 53. Here all the halogen atoms possesses higher electronegativity. As we go down in periodic table, the atomic number will increase. As the atomic number increases, the bond length will be increases. All the halogen atoms here on C bond X that possesses partial negative charge, and here carbon possesses partial positive charge. For example, here CH3F, here the bond length between carbon atom and fluorine is 139 picometer. CH3Cl 178 picometer, CH3Br 193 picometer, and CH3I 214 picometer. So here, as we go down in periodic table, atomic number increases and their bond length is increases. So this is the nature of C bond X bond. Now let's see another topic, that method of preparation of haloalkanes. Number 1, from hydrocarbon, or we can write here from alkane, by free radical, by electrophilic substitution reaction, or by Sandmeyer reaction. Here from alkane compound, it is prepared by addition of halogen halide, or addition of halogen. Number 2, from alcohol reaction with hydrohalic acid, here HX, here HCl, HBr, HI, or HF, etc. In presence of sodium bromide, NaBr, in presence of PX3 or PCl5 or red phosphorus and halogen here chlorine or bromine, and thionyl chloride, SO thionyl Cl2 chloride, thionyl chloride, and number 3, that is by halogen exchange, it is Schwarz reaction. Okay friends, so this is the method of preparation of haloalkanes and haloarenes. Let's see number 1 from alkane compound, or you can write here from hydrocarbons. Most of the halogenation reaction is carried out. It is substitution reaction. Here free radical mechanism and nucleophilic substitution reaction. Okay friends, so here most of the halogenation reaction is carried out, that is substitution reaction. Means substitute means what? Here for example, here hydrogen atom is replaced by chlorine atom, is called substitution. Okay, so now reactivity of halogen, that is fluorine is greater than chlorine, is higher than bromine, is higher than hydrogen. So here fluorine is most reactive and iodine is least reactive. Let's see here why is most reactive. So for fluorine, here the bond between two fluorine atom, that is very weak bond, and it is easily cleavaged, so it is therefore their reactivity is very high. Suppose here methane on fluorination, all the hydrogen atom is replaced by fluorine atom, so we get here direct fluorine compound, here CF4, so tetrafluoro methane. Okay friends, so here direct fluorination is carried out. Is methane. Let's see another example of fluorination of this ethane. Here all the 6 hydrogen atom is replaced by fluorine, and we get product C2F6 hexa fluoro ethane. Okay friends, so here now for chlorine, here the bond between two chlorine atom is strong, and by chlorination of methane in presence of sunlight. Here for sunlight we have to write HV or H nu, but in absence of sunlight at higher temperature chlorination is carried out. So that temperature is round about 250 to 400 degree centigrade temperature in vapor phase. So this is very most important. Either sunlight is required or higher temperature is required. So here free radical mechanism is carried out. CH3Cl plus HCl chloro methane. Here one chlorine atom uh, is attached with this HCl, sorry, H. Here one chlorine is attached with this hydrogen and we get hydrochloric acid, and another hydro is replaced, that is chloromethane. So let's see here on again chlorination in presence of sunlight, we get CH2 Cl2 dichloromethane. Again on chlorination in presence of sunlight, we get trichloromethane, or we can write here chloroform. Again on chlorination in presence of sunlight, we get CCl4 HCl carbon tetrachloride, or here tetrachloromethane. Now here iodination, the bond between two iodine atom is very strong. So the reaction is carried out very slowly. Methane on ionization, we get methyl iodide and hydroiodic acid, or here we can write iodomethane. This hydroiodic acid is strong reducing agent, and because of this strong reducing agent, the reverse reaction can be carried out and further it is converted to methane. So to stop this reversible reaction, a strong oxidizing agent is added to reactant. The strong oxidizing agents are nitric acid, HiO3, iodic acid, or mercuric oxide. So strong oxidizing agent is very most important to stop the reversible reaction. Sometimes you will be asked in examination which type of mechanism is carried out. So whenever you have to find free radical mechanism, you need to remember these 5 character: HELPR, help R. H for, suppose here a reaction is carried out at higher temperature, the free radical mechanism is carried out. Suppose here reaction is carried out in presence of electricity, that means electrolysis is carried out, free radical mechanism. Suppose here L for light, or here we understand about sunlight, the free radical mechanism. And for P, that suppose reaction is carried out in presence of organic peroxide. Here these two oxygens are free radical, so reaction is free radical mechanism. And for R, it is free radical is formed during the reaction. Here for chlorination, on cleavage we get here this chlorine free radical, so this is called free radical mechanism. So this is very simple formula, HELPR. Let's see another example. Suppose here CH3 CH2 CH3 is called propane. On chlorination in presence of sunlight, CH3 CH2 CH2 Cl, we get 1 chloro propane plus another product, that CH3 CHCl CH3, it is called 2 chloro propane. So friends, here the main question is that how can you identify either this will be our major product or minor product, or this will be major or minor product. So here the reactivity of this 2 methyl group is same compared to these methyl groups, it is CH. So the reactivity of this CH2 group is little bit different compared to these 2 methyl groups. So in first product, chlorine group is attached with either this carbon or this carbon. There is no difference about our product. And for another product, chlorine atom is attached with this second carbon, so we get here 2 chloropropane. So for to identify the major product or minor product, we need to remember the stability order of haloalkane or alkyl halide. That is, tertiary is more stable, then secondary is more stable, then primary is more stable, then methyl free radical, this free radical. So here the least stability of is least stable and this most stable. Okay, so in this product, this is our primary alkyl halide and this is our secondary alkyl halide. So according to the stability order, secondary is most stable, that will be our major product, and then after primary, that is our minor product. So it is very most important for examination aspects also. And sometimes you will be asked another question for MCQ. This will be our position isomer also. Why? Because in first product the chlorine atom is attached with first carbon, and here on simple, the chlorine the position of chlorine atom is only change, so this will become position isomer. So you can write here for normal butane on chlorination in presence of sunlight. Try yourself. Let's see another example. Suppose here for cyclohexane on chlorination in presence of sunlight, we get chlorocyclohexane and suppose here for cyclopropane on chlorination in presence of sunlight, we get chlorocyclopropane. Or by electrophilic substitution reaction, uh, benzene on chlorination in presence of FeCl3, chlorobenzene will be formed. Or suppose here bromination, benzene on bromination in presence of FeBr3, you will get here it is called bromobenzene. Okay, so this is for electrophilic substitution reaction. Let's see another example. Methyl benzene, or its common name is toluene, on chlorination in presence of FeCl3. Here FeCl3, FeBr3 is act as catalyst. We get orthochlorotoluene and another product CH3Cl, parachlorotoluene, because this methyl group is ortho-para-director also. This will be our position isomers also. Is very most important for MCQ also, or in competitive examination. Let's see another mechanism or reaction Sandmeyer reaction. First of all, primary aromatic amine react with sodium nitrate and HCl at 0 to 5 degrees centigrade, or you can write here 273 to 278 Kelvin temperature. You will get benzene diazonium chloride. It is called aniline, and this is benzene diazonium chloride. And this benzene diazonium chloride and react with cuprous chloride Cu2 Cl2 we get here chloro benzene. In short, we can write here BDC by benzene diazonium chloride. Here benzene diazonium chloride and react with cuprous bromide Cu2Br2 cuprous bromide HBr. Product will be formed bromo benzene. So friends, this is Sandmeyer reaction, the BDC to chlorobenzene or BDC to bromobenzene. Sometimes you will be asked in examination a conversion aniline to bromobenzene or aniline to chlorobenzene. So these two steps are carried out from aniline to benzene diazonium chloride. This will be your first step, and second step, the reaction is carried out with cuprous chloride. You will get chlorobenzene. This will be your second step. Now let's see another reaction. Benzene diazonium chloride and react with potassium iodide. Iodo benzene will be formed with nitrogen, and here KCl, potassium chloride. This nitrogen and this potassium react with this chloride atom, and iodo benzene will be substituted with this carbon. In reaction with HBF4 or NaBF4, HBF4, that means fluoroboric acid. It is called fluoroboric acid, and sodium NaBF4, that means sodium boron hydride. Okay, you will get fluoro benzene, nitrogen and boron trifluoride. So this is not your Sandmeyer's reaction. So one thing is keep in mind that the reaction is carried out cuprous chloride and cuprous bromide. You will get chlorobenzene and bromobenzene. This is only the Sandmeyer's reaction from BDC to iodobenzene or from BDC to fluorobenzene. This is not Sandmeyer reaction. Okay friends, this is very most important. Let's see another reaction of benzene on iodination in presence of AgClO3, silver perchlorate, AgClO3 silver perchlorate. You will get iodobenzene, Agi silver iodide, and HClO4 perchloric acid. Suppose here bromination is carried out in presence of FeBr3 bromo benzene that we have discussed earlier also. Okay friends, so next time we will discuss another topic. Thank you very much.